Okay guys, so today we're going to have a look at the practical that carries on from the concentration and rate of reaction information that you should have just watched through. So we are going to run through the practical quickly. I will demonstrate what it looks like, how to do it, and then hopefully we should be able to collect some results for you so that next lesson you can plot your graph and do your analysis and your conclusions. So concentration and rate of reaction practical. Now note, we're encountering a brand new chemical today. You guys will not have encountered this before. It's this sodium thiosulfate here, Na2S2O3. Now the reason we're using this chemical is that when we react it with the hydrochloric acid, it produces pure sulfur, the element sulfur, which is a yellowy solid. So it's really easy to detect how fast the rate of reaction is going by how quickly the solid appears from the two colourless solutions, which I'll show you in a bit. So we will be measuring out 50 centimetres cubed of the solution in a measuring cylinder as usual, put it in a conical flask, and 5 centimetres cubed of hydrochloric acid to react it with. To objectively measure how much solid is formed as best we can, we are going to use a big X on a piece of paper that will go underneath our conical flask, and when we can no longer see the X, we know has enough solid has been made to stop our stopwatch. So we will add the hydrochloric acid to the thiosulfate solution, start the stopwatch, and very importantly we will cover the flask over the top with some cling film or cling wrap. Now this is because when this reaction happens, sometimes we get small amounts of sulfur dioxide made, and that's that horrible sort of eggy smell. It's not nice, and it's not very good for you to breathe in. So the cling film is there to stop the gas coming out of the conical flask so that we're nice and safe. So we'll look through the solution at the X marks on the paper, and then when we can no longer see the X, we press stop on the stopwatch, record the time for X to disappear, and then most importantly dispose of the contents into the chemical waste in the fume cupboard as we usually would, because if there is any of the gases being produced, it can go up the fume cupboard and not fill up the lab, although there'll be less than usual. We're going to repeat the experiments with fresh solutions of different concentrations. Now the way we're going to get these different concentrations today, guys, is by varying the amount of water added to our thiosulfate. So like we talked about in the last video, by adding water, by increasing the volume to something of the same concentration, we will lower the concentration. Now the first thing to note for you to put onto your worksheet is, in the first experiment we'll have 50 thiosulfate and 0 water, and the concentration will be 0.2. It's pretty easy to work out then that if we have 25 thiosulfate and 25 of water, we've halved the amount, so this would be 0.10. Okay, then we can work out the concentrations of the others. We're changing it by 5 centimetres cubed each time. The difference, if we split this by 5, must be 0.2, so 0.02, sorry, and then that means this must be 0.18, 0.16, 0.14, and 0.12. So we're changing it by 0.02 each time as we dilute it by 5 centimetres cubed extra of water. Okay, note we're keeping the actual volume, the total volume, constant by doing this. They all add up to 50, which is very important, otherwise the concentration wouldn't be changing very much. Wouldn't be the same change in concentration every time. Okay, so now on to the practical. Okay guys, so I'm only going to demo 3 of the 6 that are on your sheets, because there's no point in wasting your time watching all of them. So I'll demo the 0.2, the highest concentration, the 0.14, so the fourth one down, and the 0.1, so that you have an idea of the time differences between them. So we'd have our conical flask, our cross, our measuring cylinders as usual, and let's measure out our chemicals. So I need 5 centimetres cubed of the hydrochloric acid. There's my 5 centimetres cubed. And I need 50 centimetres cubed of my thiosulfate to do the 0.2. So there we go. And check, yep, So let's put that in with our photographic over my cross. I have my cling film ready for the start, and I'm going to position you over the cross now so that you can see it disappearing. Okay guys, so this should be our highest concentration, so hopefully this will have our highest rate of reaction as we would predict. So we're ready to go. As we can see, it's changing colour, and the cross is gone. 2438. Okay guys, so this time we're going to do the 0.141. So we will need to dilute down our sodium thiosulfate to a certain extent using some distilled water. The easiest way to do this is in the measuring cylinder before you put it in the conical flask. So again, we need 5 centimetres cubed of hydrochloric acid. We're not changing anything about that chemical, having the same amount of hydrochloric acid for reactant every time. So let's check that's 6. That's too much. There we go. So let's pour out a little bit. A bit better. Tiny little bit more. There we go. And this time, as our table says, we're going to need 35 of our thiosulfate and then top it up with 15 of water. So let's measure out our 35. There's 35 in that, and then we top it up with our distilled water to 50, so that we have diluted. Now it's important to give it a little bit of a swirl when you put it in your conical flask, because we don't want all the thiosulfate sitting at the top with the water and the thiosulfate nicely mixed together. Again, I'm going to push you over the top. Okay guys, so we have our 0.014. Hopefully you can see the cross through the camera, okay, and you should be able to see the timer. So I'm going to add my hydrochloric acid and start the timer at the same moment. So, and put my cling film over to stop the gas coming through. So hopefully we're starting to go a little bit cloudy. I can see it's going a little bit cloudy from just outside the camera. You guys can hopefully see it slowly disappearing. And ooh, it's gone. So 35.97. Okay, then our last concentration we're going to look at is our lowest concentration, our 0.10. I've measured out my 5 centimetres cubed of hydrochloric acid already, so now I need my 25 centimetres cubed and my 25 centimetres cubed. So let's get that 25 of sodium thiosulfate in, and then we can top it up with our distilled water. So obviously much more water than the chemical in this one. And again, like our last one, when we put it into the conical flask, we want to make sure we give it a good swirl so that the water and the thiosulfate are completely mixed together. Okay, so this is our lowest concentration, our 0.10. So let's get ready to start stopwatch as before. Cling film. And hopefully you can spot in comparison to the other two, it's taking much longer to start going cloudy and disappearing. We're almost almost at the 35 seconds that the 0.14 did, and we're only just starting to lose focus on it. And nearly there, and disappeared. 50.65. Okay, so hopefully you have been through the video, seen all the results. I've run the other experiments that we didn't show you as well, so here is some data for your results table that you can use during the next e-learning session to calculate your rate and draw your graph when that is set. Have a good day.